illegal for reasons we've talked about. So, what you have to do is dispatch that, and there's a dispatcher, a WPF dispatcher, and you dispatch it to the main thread. Basically, the window application provides a function that's intended for the main thread to run that says, put this thing in the list box, or write this text in the text box, or whatever. And then this guy creates what's called a delegate. You can, if you haven't taken SMA, think of a delegate as a standard function. It's will bind to lambdas and stuff like that. And so, you just, this guy, the receive thread, will take that, whatever text, whatever content needs to be displayed in the window, and it will create a lambda, bind it to a delegate, and dispatch that delegate. And what that's doing, what the dispatcher does, is simply it posts a message to the underlying Windows queue, and then it sends a message, a custom message to the window saying you've got a delegate to call. Go call it, and that gets the thing put in the window. And if I can find that, some code like that on my laptop, we'll look at it. So now, and I will talk about WPF and C++ CLI on Thursday and the next Tuesday. And I'll probably talk about WPF first because you can work on this before you actually hook it up, and then I'll talk about C++ CLI second. And it's a quick conversation. C++ CLI, for what you need, this is so simple. It's just a little delegation. You don't need to know a whole lot. I'll tell you, a little more than you need to know, but it's a fairly quick conversation. So that's my model of Project 3, and I think this is like an afternoon's work. Not much, just pull a message out of the, So this thing is here. I ran it for you in class yesterday. It's there, and so you can grab that and just build a console application that hosts that COM, and and then from a console application you can just push little messages in and get this guy to handle those messages. Okay, afternoon, you're done. And then you can work on the GUI, and then as you know enough about C++ CLI, and you don't need to know too much, you can add this part, and pretty soon Project 3 is all done. Okay. Questions about this? Yes?
All the three executables will be up and running at the same time. All the three executables will be up and running at the same time.
So there's only really two executables here. So this is really, this part is part of this executable. This part is part of this, but this is going to be built as a DLL, not an executable. And this guy will load the DLL. So what happens is this guy compiles to the intermediate language. It's C#'s equivalent of Java bytecode. And this guy, because it's managed code, compiles to, guess what, bytecode, the equivalent, intermediate language, the equivalent of Java bytecode. And so, because it's bytecode to bytecode, this guy can load the library and, and access it. Okay? But the interesting thing about C++ CLI is that I can interact between both managed objects and native objects. The only language I know of you can do that. The closest any other language comes to that is Java with a JNI, which is awful. JNI is awkward, clumsy, and it's no longer write it once, run anywhere. Okay? You got to tinker with it on each platform, tinker with the JNI to get it to work right. So, It really is a nice mechanism. Yeah, you kind of get, for a while, a little like bipolar disorder or something, you know, or some, because you're writing managed code, but using C++ syntax, and you can, for a while, you kind of get dizzy, you know, trying to keep track of, but, you know, it only takes a little bit to get used to. Any other questions about this? So there's several ways we can go from here. We can talk about requirements. We can look at the communication code. I can pull up if I can find it, C# console application and look at that. How many vote for requirements? Nobody. One. Okay. How many vote for looking at the COM code? Okay. How many vote for looking at a C# application? Okay, so let's look at the COM code first, and then we'll try to pull up a C# application, and then we'll go to requirements. Jessica was the only one who raised her hand. That's okay, Jessica. It's okay. It's a cross you have to bear to have me know your name. Okay. Okay, so let's look at some code. COM. Yeah. Oh, yeah. Let's go to HTML. Okay. So, first of all, let's just look at the Solution Explorer. So what we see here is there's a blocking queue which the COM system uses. We'll see it in a little bit. And, you know, we talked about the blocking queue during, you know, while we were talking about concurrency, the condition variable guy. There is a message class, and message passing COM is the communication channel, and sockets and some utilities. The sockets you really don't, I'm going to look at them a little bit just to remind you of things we talked about in class, but you can kind of ignore sockets and just use the COM, you know, because COM hides the sockets from you. Not doesn't totally, but mostly hides the sockets from you. So, so why don't let's take a quick look at the sockets. There's just a few things I wanted to point out to you. So as the diagram I showed you said, there's 3 classes. There's 4 classes because there is a system socket class. And notice it just has a constructor and a destructor. And if you look at the implementation, a constructor calls WSA startup, and a destructor calls WSA shutdown, and that's all it does. That's all it does. There is actually some functionality that you could put into this class that accesses the DNS servers and stuff like that that are really system-y that would be useful to have there. And years ago, I had a version of sockets where I did that. But when I moved to this, I didn't get around to putting it back in. Maybe it'll be a summer project for me or something. Put some of that back in. But for now, that's all it does. And the basic socket class, you can tell it IP4, IP6, and the only place this really matters is in the socket listener. Because the listener will listen for a address and a port, and if you say IP6, it'll listen for an IP6 address. If you say IP4, it'll listen on an IP4 dotted quad address. In order to listen on both, I think you really have to have 2 listeners. I haven't looked at that real hard, but I think you'd probably have to have 2 listeners to simultaneously listen on both. And my COM doesn't support that. It'd be, again, a decent summer project to the COM receiver, provide two listeners so it can listen for both addresses. But, right now, I mean, you could do the same thing just by having two receivers, one receiver with an IP4 address and one with. Notice that the copy constructor and the assignment operator are delete, but the move operations are implemented. And the idea here is that it really doesn't make sense to have two different threads or entities own a socket. Because if you do, one will go grab some stuff out of the socket and the other one is expecting to, and that stuff that it wanted to grab is gone because the other guy got it. A whole opportunities for all kinds of confusion. So, I think just changing ownership is the right way to do it. And what happens is my listener, what it does when it hands the thread, it moves the socket into the thread. And so the listener no longer, it's temporary, the listener doesn't care about that socket anymore. And so it just moves it, it gives the thread ownership of that socket. That's the right thing to do. There's a send function. Notice it returns bool. So no integer, size t bytes, byte buffer. So let's go look at its implementation. So sure enough, while bytes left, I'm sitting here making sure that all the bytes got sent. That's all. Piece of cake. And same thing for receive, So if I don't return, I do have a version that returns an int, I think. Yeah, the send stream and receive stream are really just send and receive. Okay? And where your model is, you're just sending a stream of bytes. And you could use that for file transfer. I don't think I did, but you could use that for file transfer. I originally wrote it to use for file transfer, and I maybe use, I don't remember, Once I write some code, and then 2 weeks later, I've forgotten what I wrote, That's why I'm such a stickler about comments and good structure and stuff, because I forget, and I don't want to spend hours and hours, trying to reconstruct that. One of the most important things for us is this receive string, because we want to read those attributes out of the socket. And it defines a terminator, and I have removed terminator. And so what's going on? This terminator, you need to, I want to return the terminator with a receive string so that it gets the new line, and any interpretation out that sees the new line is a yep. So that's the end of this, whatever. So my new line terminates the string, but if I really wanted to grab a whole string, I would just put, and I do by default, a null terminator, and that will grab the whole string. But this would grab all the headers. So what we want to do is, for our messages, we receive string with a /n, new line, terminator. And I intentionally add the terminator. I don't strip it off. A lot of functions that do these kinds of things will strip off the terminator. I don't, but I give you a way of quickly removing that last character in the, what you just pulled out, remove terminator. It understands what this terminator is. It remembers what that terminator is, and so you don't have to tell it anything. Just remove terminator. And I can look at my buffer, my socket buffer, and say how many are there any bytes. If for some reason I don't want to block, I can do this bytes waiting. Okay. So. And wait for data is just I'll sit here. I use this sometimes when I start up a client and the server starts up slower, and I don't want the client to shut down, figuring that the connection failed. If I never start the server, eventually that client should shut down. So what I'm doing here in bytes for waiting or wait for data, is time to wait and the time to check. So, so this time to wait is the total amount of time I'm willing to wait for that server to come up. And this is some fraction of that, that's the rate at which I'm going to check to see if this, if I made this 0, I'd sit there with a spin lock and my CPU utilization would go to 100%. Pegged to the wall. Okay, can't do anything else because I'm pegged to the wall, waiting for that event. Okay, so the spin locks are, a fast way to do locking, but you only want to do it when you're absolutely positive that the locking time is really small, because otherwise you'll just pin the CPU resources to. Operating systems use spin locks, and I occasionally will use them, but you got to be really careful with them. And then shut down send, shut down receive, shut down graceful way out, and then closing the handle. And I can test, I've got a function to test is the socket in a valid state. And there is in Windows an invalid socket, but this would be something different in Linux. And so I did it this way so that the interface will stay fixed, whether this is Windows or Linux, but it's easy to report. And down in the data, there's some Windows-specific stuff down here. This WSA data, blah, 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 blah. But anyway, so that's the nature of this socket class. And then there's a socket connector, and all it does is it adds connect, really. Okay. So I've got a virtual destructor because, I might decide to derive from this someday. And I'm implementing the move constructor and the move assignment. But connect is the main thing, and so let's go look at connect. So here I'm converting for the network order, and doing a little manipulation of the endpoint, and let's go to full screen. So, I'm resolving the address, okay, and then now I'm going to attempt to connect. So there's quite a bit of bookkeeping you have to do because I'm using IP6 I'm supporting IP6 as well as IP4. IP4 is significantly simpler, so a lot of this stuff is just IP IP6 stuff. But eventually, I call the underlying API connect with the right stuff for the addressing mechanism. Again, this is more complicated than the slides I showed you because IP6 got complicated simply because it wanted to build, it didn't want to tear apart all the IP4 stuff, So now, instead of having just a pointer to a structure, which is what IP4 has for the addressing stuff, now it has a pointer to a pointer to a pointer, and several linked lists. Trying to keep track of this much bigger set of things that IP6 has to worry about. So, but you don't need to worry, but you don't need to know all this stuff. I don't know all this stuff. I learned it to do it and then forgot it. And I don't want to remember it, okay? Your head can hold a lot of stuff, but it can't hold everything, okay? And so some stuff you really ought to say, I don't need that, put it in the dustbin, put it here in this safe archive so that if I do need to, yeah. So, and again, socket connector was publicly derived from socket. Okay. And now here's my socket listener. And now notice that I have our old friend, the template method. And you thought that was some weird thing that I don't need to know that. Template method. So here's the template method, callable object, start. So this is how I tell the listener what it's going to do. Okay. And if we peek at it, so I attempt to bind. So that attempts to bind the listener to a network card. I attempt to put it in listen mode. And these are functions that I wrote, bind and listen, that are, elaborations on the API calls. And now I'm going to start a thread, listens. So that listener has a thread automatically, okay? So you don't have to supply it. It's gonna run. So this listener, when it blocks on accept, is not going to block your main thread of the main thread that's using the receiver. Not, because the listener is running on its own child thread. Okay. So, and of course it's a lambda. So, while not accept failed, okay, socket client accept, okay, so, and this is checking did it fail the last time, essentially. So, if not client socket.valid state, go back and try again, but otherwise, and the static logger allows me to log stuff. And, I should have removed this. So here's my standard thread, client thread. Here's my callable object, standard move. I'm moving the socket into the thread. Okay. And now I'm detaching the thread, because I just want that guy to free run. I don't need to check him and my main stuff. I just want him to run. So. Now let's look at I define that in the CPP. So let's look at com.cpp, and let's go up. What I'm looking for is my wherever I put that. Maybe right at the top, because I don't expect it to change much. Sender thread, we want to look at that too. Okay, let's just walk down this a little bit. So here's my start function, listener.start. We got to see where we called start. And then, my receiver has a get message, and it's just going to its receive queue and dequeuing stuff out of its receive queue. The sender, so I'm just giving the sender, so I am constructing the sender. I can give it a name, okay? And I'm keeping track of the last endpoint. So what I'm doing now is, when I'm constructing the sender, I give it a default endpoint. That's nothing in it. But what I'm going to do is, this sender is, remember, the send thread is the guy that sits between a send queue and a socket. And he's got to look at that he's going to look at that message and say, is this endpoint, the to address endpoint, is that the same as my last endpoint? If it is, I just send it. If it isn't, I close the socket and I open a new connection. I'm doing stateful message inspection. So here's the sender start. Here's my thread proc. So this is what the send thread is doing. So, you know, and I allow you to shut it down with a quit message. And so if message to address is not equal to the last endpoint address, or message to port is not equal to the last endpoint port, connector shut down, close the connection, and then now I'm attempting to connect to this new guy. But that may not succeed because he may not be listening. Okay? Maybe my parent thread, the thread in my, that's composing that message, wanted it to go to this guy, but, he didn't know what it was. So I'll find out if I can't connect to him. Okay. If I can't connect, I continue, and what that's going to do, basically what I'm doing is I'm printing out a can't connect message, and I'm dropping that message on the floor. What I'm doing. But there's some interesting things you could do here. You could have a dead letter queue, dead message queue. And so if I can't send it, I could put it in the queue. And the next time I connect to that guy, I rip everything out of that queue and send it to him before I give him the message. And so now what I'd want is a structure that has both I'll have a map that has the key as an endpoint, and the value is the queue of those messages, and a connection. So my value is a struct that has a connection in that queue. And that way, I can keep a connection alive indefinitely if I want to. I'd probably want a background thread, so if I haven't used that connection in the last 20 minutes, close it down. But that would allow me, if I'm busy talking to a lot of different people, it would avoid me constantly opening a new connection that I talked to 5 minutes ago. Okay. But none of that's here. It's all just cool things to do if you wanted to do it. Now, I'm not suggesting you're going to do it. It would be crazy for you to do that kind of stuff now. In either project 3 or project 4, you got to be done by by the beginning of May. But it's something cool to do. Maybe you want to work on a project over the summer or something. So anyway, that's the way that works. And now, if the message contains key file, send file message. So now I go into a function that's going to send files. Okay. If it doesn't have that file key, then this is just a message, and I go back and try to pull another message out of the queue. So that's that. And sender stop just sets it down. Post message, just this is a function that the main thread calls to give this send thread a message. Just accuse it in the send queue. And here's the send file. You can look at it, but basically, while true, I keep reading buffers. I keep reading blocks out of the buffer and building a message and sending the message. Another block, build a message, send it. Another block, build a message, send it. That's the way it works. And I like this. In SMA, I wrote a channel that a lot of you guys use that had a rather different process, but it didn't send the files over message bodies. And I like this better. This one mechanism to send whatever you want to send, a file or a message, It's just everything goes as a message. So it's nice, clean, simple idea. Not that the implementation is trivial, it isn't, Callable object post incoming message to receive queue. So this is the client handler. This is the receive thread. Okay, this is the handler for the receive thread. And so Now, my listener, I got to remember what I did. My listener is holding a pointer to a queue it created, I think. I'm doing that. Let me go and look at the listener. Yeah, receiver. So that's not where, here's this receive queue. Where did I do that? Where's this guy defined? Oh, this is, okay, so this client handler, I'm giving it a pointer to the queue, and I got a function. So I've forgotten where I actually created that queue, but I've got one place that creates a queue, and each client handler gets a reference to that same one fixed queue. So all the client handlers are dropping messages in the same queue. Okay. So, we could click on that and references and figure out where I did it. But we may see it yet. Oh, yeah, here's where it comes from, right here. In my start function. So my COM has the receiver has a receive queue, and so when I call start on COM, I'm really just starting the listener. That's all I'm doing. And so now I'm taking a pointer to that receiver's queue. So the receiver is the guy that creates the queue. He's taking a pointer to that receiver queue, and I'm passing it the client handler, pointer to the client handler equals new client handler, and in the constructor, I pass him the pointer to the queue and the name of the, I give him a name if you want to give him a name, just for output so you can see who's. So that's how everybody shares that queue. No static queues in this design, which is better. The only reason I made queue static in the SMA design was that Windows Communication Foundation hid all that stuff from me, so I couldn't do this because that would be down in the bowels of WCF. Shame on them for not giving me a buck. Maybe they did, and I just didn't know it was there. Who knows? So yeah, that's the way the COM works, and you can look at this test COM and get an idea. Here's how you use it. Socket system SS. So that's just gonna, I don't have to do anything else. You'll see no other reference to socket system. This is gonna call WSA startup, and when I exit the scope at the bottom, it's gonna call the destructor, which WSA shutdown. Okay. So, and now, I define an endpoint port equals 9091, endpoint address equals localhost, receiver RC1, endpoint 1. So this receiver is going to listen on 9091, and blah 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 blah. Client handler, So it's not too hard. Just by looking at the test stub, you can see how to use it. Test stubs are great for several things. They are construction tests, so you can test as you build, and you always should, but also their documentation. So somebody else who wants to, you don't have to give them 15 files. You give them that one set of code, and they can look at the test stub and see how to use it. Okay, so I think I'll stop here with the sockets. Now let's look at the communication system just a little bit. And that socket stuff you can ignore. Unless this summer, you want to play around with dead letter queues and that cool stuff. So let's look at message. I looked at this in class, so I'm going to be real quick about this morning. So, my message class is a pretty full-featured class. This is a HTTP style messaging. It isn't an HTTP message because I'm not declaring the command get, put, post, and delete with the syntax required by HTTP. Okay. I do that in CPP, HTTP client and server, which by the way isn't quite done. But all that's set up, getting that command syntax correct is set up in those classes. But here, I'm using an HTTP style, but and so my endpoint, I have an address that's a string, I have a port that's a size, and I have a constructor that will take those two arguments, and it just builds a struct. This is just fills in those values, and I can convert it to a string, and I can parse it from a string. So I can take an endpoint and make a string out of it, and then later on, if I want the host or the port, I can just from string and grab the host and the port. And some, here just implementation. I did this inline, and here's my message class. So I have a key defined, value type defined, attribute defined, which is a combination. It's a key colon value, and I have attributes, which is just a unordered map of keys and values. And because I'm using it as an unordered map, it makes it really easy to access stuff. And so, I can build custom attributes. And so here, a lot of what you'll probably do is you'll be building custom attributes. I provided you mechanics for to addresses and from addresses and a few simple things. But here, for example, you want a message ID, so you can, I want this to be a check-in. I want this to be a checkout. So you could use a string key if you wanted to, or you could use a numeric ID, whatever you want to use. And so, a lot of what you're going to be doing is using these custom attributes to shape your message so it does the kind of things you want to do. So a lot of what you're going to do in Project 3 is really message shaping. Tom is up there and going for you, it's just message shaping and you figuring out how the flow is going to go. That's very typical of asynchronous message passing. Once you have the channel design, channel is one of the harder things to do. There's a fair amount of stuff, fair amount of thought went into this, fair amount of debugging, fair amount of teeth clenched. What the hell is the matter with this thing? Okay, but once that's done, mainly what you're doing when you're designing message passing systems is you're deciding what's my message flow going to be in the system, and what's the structure that what do I need to do for the messages? What attributes do I need? And how am I going to dispatch them? So anyway, and there's a file, that tells it this is you need to send a file, and there's a content link that says I got a buffer full of stuff, blah, 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 blah. So that's my message class, and then my message passing COM is, just what we took a quick look at. So it starts out with a receiver. And the receiver, you start it, you stop it, and you post a message. What you do? Piece of cake. How can it be so easy? And Naga's grinning. You know enough to be careful when I say that, don't you? And the sender, piece of cake. Start. Stop, connect, post message, piece of cake. If I could do it, I would do a John Travolta Saturday Night Live thing, Do you know who John Travolta is? You know what Saturday Night Live is? Not Saturday Night Live. It was a movie. Here's the first thing he did. He was a young working guy in Brooklyn in the 60s, and he loved to dance, and that was when disco dancing was a big thing. And he was the heartthrob of all the local young ladies because he did this wonderful disco dancing and stuff like that. And if I could emulate it, I would. Just like I'd love to be able to do the Michael Jackson moonwalk, you know. But I can't do it. So, you know, and then COM just ties them together. That's it. Send message, post message, piece of cake. Okay, and so, sure enough, in our diagram, what do we got? Send message, post message. Nothing left for us to do. Why didn't you leave us more to do, Dr. Fawcett? Any questions about that? I've heard more than I want to hear about. Yes. Hey.
Could you please explain more about the map?
Are we talking about message or are you talking about this diagram?
I know just that you mentioned earlier, we will use a map.
Well, I've talked about that a couple of times, but what I think you're referring to is this conversation. I said, so let me put this DocCam view up again, and then I'll draw on the board. So over here, we're going to get messages, and what you want to be able to do is post those messages to some useful functionality. Each message is going to have different functionality. You know, in Project 3, it's not going to be much more than writing to a console, I'm a check-in message, I'm a check-out message. But in Project 4, it's going to be the real thing. You're going to invoke activities in your repository. And I think a really nice way for a server to handle messages is to dispatch them. So, so you have a, let's call it message dispatcher. And this is really just a little thin wrapper around a map. And so I'll say message dispatcher, my dispatch. And what this is, you have a key, and you have a value, and this this key is this key is some kind of a message ID. It could be a number, or it could be check-in string, check-out string, you know, whatever you want. But suppose we did this as a string, and so this is, for example, check-in. That's my key. And my value is going to be a callable object. So now this is a callable that does processing for its for message with key equals to ID. Whatever. So for Project 3, that callable object is a little lambda that says standard cout. I'm a server received a check-in message, and then it posts the message in that same call. posts them. It builds a little tiny message, a reply message, and posts it to the back to the GUI. And maybe you'll put on the status bar of the GUI, notified that the server received client message or something. You know, whatever you want to do. Your design. But now, you know, so I have for each key, you know, I have check-in, check-out, blah, 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 you know, just different keys and different callable objects. One callable object for each kind of thing I want to do. And now that makes it really easy to add more functionality to your server without tearing anything else apart. You don't have to take the scissors and snip, 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 and get arterial bleeding that you got to go suture, 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 suture. Okay. 2 ways to write software. Make it so simple that there are obviously no deficiencies. Or make it so complicated that there are no obvious deficiencies. So, no snipping, no surgery, just a simple little add, new key, new attribute. Bingo! Gotcha! Right, Jessica? Right, Tharut? Wake up, Tharut. Are you with us? Not sure. You didn't get your cup of coffee this morning. Do Thais drink coffee? You probably drink tea. Do Thais drink coffee or tea? Both. You need both. I need both. Okay. So we've talked about the communication system. Are there any more questions about this structure before I pull up the requirements? Any other non-requirement related question? Yes.
Should we need to support multiple clients? Should we need to support multiple clients?
Yeah. Piece of cake, though. Come, John already does that for you. All you gotta do is connect. Okay.
Then we have to
Now
multiple
remember that you've only got one thread pulling messages out of the queue. So I can have a message from, in my queue, I can have a message from client 1, a message from client 2, a message from client 3. It doesn't matter. He's just going to pull them out and process them.
We have to provide multiple WPF, like we use.
No, no. You just run the GUI twice. Okay. Make things easy. Okay. The art is to pick up your chisel and your hammer and chisel away all that complexity until what you're left with is really simple.
We have that we use.
Example of what?
Shim.
Yeah. Oh, shim. C++ shim. I do. I don't. My hesitation is I don't really want to talk about it before I talk about it. It'll take us, so that'll get me all into C++ CLI and blah, 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 Just trust me, it'll be simple, not too much to get your arms around, and I will talk about this, I think, on Thursday of next week.
About ownership, should we give the ownership at the start of repository?
You don't have to support repository functionality.
Normally.
In Project 4, you'll definitely have to demonstrate that a change of owner, different owners with different, definitely have to demonstrate you can do that. I don't know who a repository's owner is. All I know about is owners of files. Maybe the administrator owns the repository. Yeah, but there's no requirement to implement admin functionality. Be a good thing to do, you know, were I building this for myself at home, I would add admin, would add it. But there's no, I don't remember there being any, when we pull up the requirements for Jessica, we can take a look and see, but I don't remember. Before I pull up the requirements, let's see if I can find the C++, the C# console app. So I think in SMA, I did a client app. Let's see if I can find, let's go to. So let me go to SU 681 code. Project forever. Project free help. Pluggable repo client, is that the one? I don't. Navigator client server, this is the one, right? Oh, I gotta be running as administrator, I forgot. Because I'm using, I have WCF. I think I had a demo that it wasn't all, but let me run this as an administrator. So this is I did this for the software modeling and analysis class, and I had local files and remote files, and I was popping up windows to show you the contents, a lot like what you have to do. Okay, let's take a little bit of a look at some of the code. This is not intended to be a design for your project. I wouldn't design it this way. But this was for a particular application last year. But let's just go look at a little bit of the code for that Navigator client. So for the WPF written in C#, you'll find a main window.xaml and an app.xaml. And behind that are, if you click on main window.xaml, you'll find main window.xaml.cs. Okay. So, and I have that pop-up. I was just generating a second window, and you may, not a bad thing to do for a good way to display the code instead of using process. You'll just pop, you don't have to do any of that for project 3. But this is the structure of the code. You'll find an app, and this is really where main is. This starts up the Windows application, and this is all the presentation stuff happens. And if we look at main window.xaml.cs, let's look at the XAML first. So let me switch these, and then no, So this is what XAML looks like. So it's markup, and this happens to be markup for the window, okay, and then what's here, there's some styling, and you know, we can ignore that. WPF always has in its window a grid of some kind. What happens is every graphical element in WPF can hold content. But for everything except panels, that's one thing. So if you want one graphical element, like a window, to hold multiple things, then you got to use a panel. And a grid panel is the default, the one you'll use 80%, 90% of the time. And that's what I have a grid window. And now, you know, I have a border with some padding, tab control. There's a tab control. And now it's tab item, tab item, tab item, tab item. That's all you got to do. Bam, piece of cake. So this is laying out that window, and you know, because I had two side-by-side local files and remote files and all that sort of stuff. You know, I've got several substructures in here that I don't, you know, it's not really important for what we're doing. Let's look at XAML.cs. So you'll notice that I have defined a thread. Now this is not a C++11 thread, this is a C# thread. And in our design, you will need threads in the client, and they have to be C# threads. C++ threads cannot run in a C# window, and they cannot run in a C++ CLI application, because that's managed application, and the execution environment is not appropriate for native threads. It's not a native execution environment. So I've got to run, on this side, I've got to run .NET threads. But this comm system, the things that, you know, managing, they're all C++ threads, but it works just fine. I have a blocking queue, and these C# threads can make a call. So the C# thread here makes a call into a post message in the shim, and that, because C++ CLI can talk to both managed objects and native objects, it can call this COM object's post message. And that post message hides all those threads. There's no intermixing. All that's hidden. Okay, so it works like a charm. Okay. And I've got a little host demo that, you know, I'll talk about. Either I could talk about it this morning or whatever. But there's a couple of things I want to, if I can find them, I want to tell you about. So, by the way, Pei, here is a message dispatcher. Dictionary string action COM message. Okay, string was the key, and action is a delegate. Okay, that is like is the equivalent of our lambda. I'm really going to bind a lambda to that. I call this message dispatcher equals new dictionary, blah, 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 blah. Okay. And now, and here I'm creating this C# thread, receive thread equal new thread, receive thread dot start, and this is just a message dispatcher that I'm building, but I want to take you to the place where here's a typical place. Here's receive thread proc. So now this is my receive thread that's pulling messages. This is a receive thread that's pulling messages out of this receive queue in my WPF application. Okay, that's this receive thread. This thread has the functionality to do that. Now, what I'm doing here is that thread, child thread, is not allowed to directly interact with the window. So what I do is dispatcher, this is a WPF dispatcher. This is not my message dispatcher that you saw me define. This is WPF's dispatcher. And what this guy is going to do, I'm giving it a message dispatcher message.com, okay? I just gave it a delegate. I gave it a lambda, okay? Bound to a delegate, but I gave it a lambda. And now what this guy's going to do is he is going to post a message to the input queue of the window for the main thread to pull out, and that custom message tells the main thread where to find this delegate to execute, this lambda to execute. Okay. So, and now the way this dispatcher works, I give it this lambda, and any arguments that I need to pass to the lambda, I do as an array of objects. The signature, that's what the dispatcher expects. I'm going to give it a message string. That's what I'm doing here in this demo. I'm going to give it a message string. So this is how you get the child thread to talk to the main thread. This dispatcher's job is to take this lambda is a function that I want my main thread to execute with this data. Put this in the status bar, okay, or whatever. And so now the dispatcher is posting a message to the Windows queue saying, you've got a dispatcher, you've got a delegate waiting for you to invoke. And when he gets that message, he goes to that delegate and he invokes it, and that delegate will say, add listbox.items.add message or something. Piece of cake. If I have time, I will look for, I may have a simpler example, one that isn't trying to do quite so much, so it's smaller. If I can find it, I will put it in the Project 3 help. If I can't find it and I have enough time, I will build one, but I don't think I'll have enough time. I got a fairly big thing I've got to do for another course this weekend, so. You guys aren't going to get much attention from me this weekend. So, but anyway, so, and this COM is a C#, .NET class that I wrote that works relatively close to what our C++. I like the C++ communication message handling better. So let's see if I can find right now a simpler example. I do have an example that isn't quite what I want to give you, but it will work. Let me go to, if we look at 687 code, Project 3 help. Project 3 help. You'll find CPP CLI WPF app. Now this is a simple app, but I wrote it in C++. I wrote it in C++ CLI, not C#, and so it is more complicated than it needs to be, simply because my code has to do all the stuff that XAML does. C++ CLI does not have a XAML compiler. And so you got to write everything in code. And XAML does a lot of stuff for you. And it's kind of intricate, fussy little stuff. So if I had the time, what I would do is take this example and convert it to C#. That would be very instructive. Even for me, I would be interested to see how much smaller. It'd be a lot smaller than this. But this is here. So and now I have to run this because it's this is WPF. I don't have to run this as administrator. Now let me go here and pull up what this is doing for you. So this is a mock channel, and what it's doing, what this guy is doing is this. I have this GUI, and my mock channel is just a C++ guy that has a function post message and get message. This is not a communication channel, but it has these two functions. It each has a queue, and there's a thread, and all this thread does is pull a message out of this queue and puts it in that queue. Not talking to any server, but it's showing you how .NET threads can interact with C++ threads. .NET thread, C++ thread. Okay. And what I would do in a demo is this. Let me see if I can find the. So I have a revised mock demo. Here's what I would do in the revised mock demo. Now I have the WPF GUI and a little C++ CLI shim, and now the mock channel. And so now this will be a lot simpler because I don't have to, I can let XAML do the XAML thing. Okay? I don't have to do all the things that XAML does in my C++ CLI code. And all this C++ CLI shim will do is forward these post messages from here to here, here to here, here to here. Okay? All it does. But what I don't have this. If I had the time, this is what I would build this weekend for you, but I don't have the time. Don't think I'll have the time, so I think it's highly unlikely that you'll see this built. But let's take a quick look at the C++ CLI stuff. Let's just run it. So I have a mock channel which is built as a DLL, and it needs to be. And now let's set the CPP CLI as the startup, and let's run it and see what it does. So here's what it does. It has this, I'm hosting a console application behind it. It's not a separate exe. What happens is if you build a WPF windowed application and you go into the properties and you change that from Windows application to console application, you still get the window, but now you get a console too. And if you write to the console, you'll see the output. That's what I've done here. And so all I'm doing is, send a message, and I sent the message, and now I received it, and I'm displaying it here. And it's just a text box, no, nothing fancy, just ugly pretend messages going here, bang, 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 bang. So, and now, if we look at, notice the mock channel, here's my DLL that I'm referring to. And here's my window.h. So I have a, WPF CPP CLI demo window. I have a pointer to a sender, pointer to a receiver, pointer to a mock channel. And now here, this is all stuff. All this stuff would be done in XAML. Okay. I mean, I would make, but I would, when I dock panel grid. When I want a grid, I just put a grid in the XAML. I don't have to do it, but I don't have XAML, and so I gotta, I gotta declare all that stuff and manipulate it. And some of it gets, kind of fussy. So controls for send message view, blah, 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 So, and there's setup status bar, this is all stuff, peek at the definition. This is all stuff, you don't do any of this if you write it with C#. None of this is here. This is just stuff that XAML does for you that now you got to do in code because you don't have XAML because you're writing this in C++ CLI. Okay, so, there's a dispatcher here and so there's a, I'm setting up the GUI, and again, all of this would be in XAML, none of this would be here. Send message, add text, get message, clear, get items from list, browse for folder, unloaded, so loaded and unloaded are events that the window sponsors, and you can react to those events. So what I will do for you, so this is here, if you want to look at it, I don't particularly recommend that you do right now. This is in Project 3 Help, so, if you want to look at it, it's here, C++ CLI WPF app. This is the COM system that we're using. We just looked at this morning, and I want you to use. I don't care what you use, but I think you're crazy if you don't use it, okay? CPP's string socket server is just a demo. It's a simpler, you'll see it's client server pared down to its fundamental parts. So it's really simple. And I'm going to run that in class on Tuesday, and we'll dissect it a little bit. And then, there's the sockets, but again, because the sockets are in here, you don't need to look at this. They're all in here, and you don't need to look at them there. And this is the communication channel, stuff that we looked at in class, just the model for the channel. This stuff. We looked at that in class. That's where that is. So what I will try to do is, on Tuesday, we're going to talk about, we're going to finish up sockets and maybe start WPF. We're going to look at string server and a couple more little tiny socket demos, but nothing. And then we'll probably start WPF. And then on Thursday, we'll continue with WPF, and if we're lucky, we might get to a little bit of C++ CLI. If I can, it would be nice if I had a demo for you by Thursday of a C# WPF API, the C# version of this. So that would have the C# GUI, the shim, and the mock channel. So no promises, but if I can, I'll try to do that. So Nag, you're good at Naga, you're good at nagging me. Send me an email maybe Monday and say, have you thought about, could you please? Okay. Okay, for Jessica, we'll pull up the requirements. Jessica, you're going to make all these people sit through and listen to. Everybody's interested in the requirements. Are you okay? I hope you're smiling. I was just making jokes. I wasn't trying to. I think I might have offended Jessica a little bit. I'm sorry if I did. I never intend to offend. I do intend to embarrass once in a while, but not in this circumstance. Embarrassment can be a great tool. If I think somebody isn't doing what they should be doing, or is doing something they shouldn't be doing, then I'll use embarrassment as a tool to try to get them not to. Yeah. But other than that. Okay, so let's pull up the requirements. Remote repository prototypes. So, gee, there isn't much here. By the way, we're now at version 1.2, and none of the functional requirements changed. The only thing that happened was I changed from version 1.1 to 1.2. I changed the date from the 3rd to the 10th. And from version 1 to 1.1, I got rid of a little footnote that was totally inappropriate for this. It was just a cut and paste error. It was from I'll take, when I do a new project, I just take last year's project and, just because all the HTML, so this is an HTML page and the HTML is all set up and so I just forgot to remove it. So I removed it. But anyway, you have a specific question, Jessica? Oh, okay. You just wanted to look at this lovely territory. Wow, that's cool. So, there aren't a whole lot of things I'm holding your toes to the fire about. I really, I want you to make progress toward Project 4. What I'm trying to do is help you partition things in a way. Think of this as agile programming. We're doing a sprint. We're getting some core functionality in place to deliver to the customer, and then the next sprint will round it out, make a nice package. Okay? Agile programming. We're not doing stand-up. Well, yeah, we are doing stand-up. I'm standing up, right? We're doing stand-up meetings. But in an agile, everybody stands up in the agile meeting. And they're not supposed to last more than 15 minutes, right? I think that's the measure. So, shall provide an asynchronous message passing. Because it is asynchronous, you can't use CPP HTTP client server because that's synchronous. Send a message and wait for a reply. That's the way browsers work. That's the way HTTP works. Now, our channel is very like that. Very similar. They both have message classes, and a lot of the code is quite similar. A lot of it's different, but I may eventually, for economy's sake, merge the two. I could certainly put a one-way attribute on an HTTP telling it, don't wait for a response. I don't want a response. I want to run this asynchronously. And add a little bit of the custom attributing stuff. And this one isn't doing fancy stuff about message inspection to see where it ought to go and stuff. So the C++ HTTP client server isn't doing that yet. So I might merge the two together just so that instead of having two things to look at, there's only one thing to look at. But that's that certainly won't happen this semester. So provide an asynchronous message passing communication channel. Now, our projects in this semester, you don't really get the flavor of asynchronous message passing communication. In SMA, we were, our model was a federation where we had clients that talked to a repository and test harnesses, build servers, and all that stuff. And now you got message flow. And the design really is designing the message and designing the message flows. When you build asynchronous communication systems, you're really designing messages and message flows. And you're designing the response to the messages. There's a sort of a new old thing called microservices. Microservices are really just message passing communication. All it is. Their model is I've got, a web server at each one of these corners, and I think it's better. That's a great place to use the CPP client server with a one-way attribute. But anyway, that's another story. So, used for all communication between clients and the remote repository server. And this does say, Harika, clients, plural. There's an S on the end, okay? So you are obligated to demonstrate that in project 3. Piece of cake. Just you create 2 instances of your GUI and send the messages and it'll all work because the communication channel was designed from the ground up to support that. Shall provide a client graphical user interface that supports tabs for the use, connecting to servers, check-in, check-out, browsing, viewing full file text, viewing file metadata. And I would accept you, instead of having a tab to view the text, to pop up a text window like you saw me do. I actually like that better because now I can open several files. Instead of having, I can view this file in this window, or I can view this file, or I can view the, if you pop them up, you can pop up, pop up, pop up, and now I can compare those files. So pop-ups are nice. Maybe I'll do version 1.3 and say, you may satisfy this requirement with a pop-up window instead of a tab or something like that. Why don't you nag me about that when you send me the nagging message about whatever it is you're going to nag me. I already forgot what it was you're going to nag, but whatever. Okay. So, and viewing file metadata. But again, you don't have a repository. I'm not, you could do almost nothing content-wise here. You need a little bit of content to show that you can present some content, but but the closer you make it to what you need for project 4, the more, the less you have to do when you get to project 4. Okay. Shall include an automated unit test suite that demonstrates you meet all the requirements of this project. Your automated test suite can be triggered in the window constructor and just write out stuff to this console window. Yeah. Yeah. Why not? Jessica is sitting there looking at me like, what are you talking about, you crazy guy? Are you out of your gourd? Probably. All right. That's the whole story. I don't think there's anything to say. Yeah, to demonstrate you meet all the requirements. As always, that's a requirement. You have to demonstrate you meet the requirements.
Yeah, I know that, so you don't have to show anything, just like.
No, so here's what I would do. There's a really good way to do this. So I would have in each view I'd have a button, a button for the checkout, and that sends a checkout message, and a button for check-in, that sends a check-in message. And now I would just here in this guy, what I would do is I would just simply call. I wouldn't trigger button click. I would just call those event handlers, bam, 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 and out goes this message, out goes that message, out goes. So all you got to do, okay, just call the message handlers. They're functions. You can call them. So your test demo can call those functions. Got to set up a message, call them. Yeah. Right, Ty? Piece of cake. Yes. Rehan isn't convinced. Other questions? I didn't really anticipate doing a second wave. I see 2 people came in for the second wave. I will quickly go over stuff that we talked about. Okay, for you 2 guys. Anybody that wants to stay can, but you're welcome to get up and leave. You know, you don't need to sit and listen to this crazy guy talk about the same thing again. So. You guys came in late. I have a handout. You came on what you thought was on time, but I didn't tell you in class what I had really. Hang on, let me get this. Just give a second. You don't have to, but you need to have to C# or C++
And then you guys will see me, right?
For those who came in for the second wave, I have a handout, and I'm not going to have enough, so I'll make some copies. I'll be right back.
Yeah.
No, this is a good from last night. This like the mail plan for this one. That's what memory. Yo, are you running?
Whom you are asking? Yeah, I think you must have
What are you gonna talk about? It's almost done. It's assignment. It's assignment.
Okay. And you TV.
Always is. You're taking this. Because it's of course. And also
Okay, I got handouts, so if you're here for the second wave, come and pick up a handout. So in the first wave, we talked about this diagram. We looked at the CPV COM with file transfer code. We looked at the sockets library a little bit, which is part of CPV COM with file transfer. Then we looked at the CPV COM with file transfer. And then we talked a little bit about this GUI, and I put up a couple of different examples. We can do the same thing. And then finally, we wound up talking a little bit about requirements, and we can do the same thing this morning if you want. So there's a handout here if you want for me. So shall we talk about this diagram? Okay. So this is the same one that I discussed in class. It was just a glyphy diagram instead of a hand-drawn diagram. But the model is that I've got a GUI, communication channel, and a mock server that does almost nothing. And this GUI has two parts. I strongly recommend that we do this in C# and then do a C++ CLI shim, translates the C# into into native C++. And you say, why would I do those two things? It's now I gotta learn how to deal with two things instead of one. You can write the whole GUI in C++ CLI. The issue is that C++ CLI does not have a XAML compiler. WPF uses, its model is that it uses markup just like the web does, web pages, very similar to HTML. And it uses code behind to handle events that go out of that markup, just like those event handlers happen to be C#, but in the web, in a browser, it's JavaScript that's responding. But this is exactly the same model. It's a good model, very, very effective model, much better than all the other GUI, so really, really nice model. The issue with C++ CLI is it does not have a XAML compiler. So you can write an entire application in C++ CLI, but now your code has to do all the stuff that XAML does, and there's a lot of fussy little details that the XAML designers took care of for you that now you got to do. So I strongly recommend that we do a C# WPF app and a C++ CLI, and I'm going to be talking about all those things. On Tuesday, we're going to finish up sockets, and we'll probably begin talking about WPF. And then on Thursday, we'll finish up WPF and talk about C++ CLI. I have a couple of examples of I have an example of the C++ CLI, complete C++ CLI demo that I'm going to show you this morning. It's in the help folder. I'm going to show you an example of a C# WPF application so you get a flavor of how they differ. What's different in C#. Okay. And when we're done with that, we can talk about whatever small questions you have about the requirements. The requirements are small, so I'm assuming there aren't too many questions. But anyway, here's how this works. We've got a GUI, and we don't have a repository. Your Project 2 repository is not part of Project 3. It'll be part of Project 4, not part of Project 3. There's a mock repository, and all it's doing, this guy, so we have a view. You're required to have a view for check-in, for check-out, for browse, and all that stuff. And let's say we're on the check-in view. You click that button, and over goes a message that says check-in request. And over here, this guy says, I got a check-in request. And then he builds a little message, and he sends that back that says, server received your check-in request. You're not checking in anything. You just demonstrated that that functionality works, that the communication channel works. And, you know, you are required to support multiple, in your demo, multiple clients. And so, you know, you can invoke this, you can call this application up twice, use the same application, you know, and it'll all work. The sockets, as we'll see, the communication channels designed from the ground up to handle multiple concurrent clients. It all just works. We'll see how in a couple of minutes. Might be, you could do it on multiple threads, but you could do it in multiple processes, different client processes. The communication channel is based on the TCP stack, and that means that you can talk from process to process and machine to machine.
So it would just be like.
Not much more than an echo server. Yeah. Could be a little more. Depends on, you know, the more you do, the less you have to do in project 4. But, you know.
So do I have to implement the
This is just a mock. This is just an echo server. Not doing any real check-in, check-out, none of that stuff. So now this guy is just a delegating layer. So why is this here? C# can't talk directly to native C++. There is something called pinvoke that C# compilers support that will let you call a function in a DLL, a native C++ or C function in a DLL, which was intended to let C# talk to the Windows API. And what that uses is a runtime callable wrapper, which on the C# side is C#, and on the native side is native C++, and I'm sure it's written in C++ CLI. So C++ CLI is managed code. It compiles to IL, but it can talk to native code. When this is compiled, I'm quite sure there's a segment that runs in the CLR, the virtual machine for C#, but there's a segment that runs native code on the platform. That's my mental model of how it works. Okay, I wasn't on the design team, so I don't know any of the details, but that's my mental model of how it works. But anyway, my code in this one file can talk to both managed C++ CLI objects and native. And so this guy can host a post message, and all this guy does is he's hosting this in a managed object. He's hosting a post message. And all this post message does is delegate down to this native post message. All it does. So this has to be built as a DLL, and this has to be built as a DLL, and they can probably be wrapped in the same DLL. And this guy then loads the DLL, and it's just, when it's compiled, it's just IL talking to IL. Of course it works. So now, you push the button and trickle, 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 over goes the message and says, I'm requesting a check-in, and this guy composes a little message and trickle, trickle, trickle. Maybe he writes on a status bar, I received a confirmation from the server. So this message will be constructed here and will be sent using the DLL. So this guy will make a reference to this DLL, and he'll just send it. Amar, maybe next week, why don't you do a little demo? Don't do their project form. But a little tiny hello world demo of a console app talking to a DLL. Yes.
Professor, you right now said that we have to display
create the message on the GUI. So do we have to use a dispatcher for doing that?
Yes, I'll get to that. Yes, you do. Okay, so is this clear? So this is my view of project 3. This is what I would do for project 3. Now, you gotta demonstrate you meet requirements and stuff. I'll talk about that a little bit. So let's take a look. Are there any questions before I leave this and go to the communication channel? So my next part of this tour is to look at this channel. So let's start out just by looking at these parts. So the COM channel has a receiver that holds a blocking queue, and the sender will use a blocking queue. There's a send queue and a receive queue. And there's a message class that that's the next thing first thing we'll look at in any detail. Message class that allows us to compose and parse messages. And then there's a communication channel that sends them, and underlying that is sockets. What I'm going to do is take a couple of minutes and look at the sockets first, and then we'll back up and look at the message class and the communication channel. So So in my sockets class, I start out with the sock system. And remember that any Windows application wants to use Windows sockets has to call WSA startup and WSA shutdown. And so I've created a single object whose constructor calls WSA startup and whose destructor calls WSA shutdown. So you just declare that at the beginning of main, and when you leave main, so at the beginning of main, you call WSA startup, and now you don't have to do anything else. And by the way, you don't have to, because the COM channel already does this for you on your behalf. So you don't even have to do it. Okay, now I have 3 socket classes. This socket is the socket that the listener returns when it returns from accept. This is the one he's going to give to a client handler to talk to the client. When accept returns, it returns this socket, a socket of this type, and that's already connected to the client. And I can declare whether it's IP4 or IP6, and it really doesn't matter except for the listener. The listener is going to listen on an IP4 address or an IP6 address. Take your pick. My sockets can't listen on both. They can. You just have 2 receivers. One listening on IP4, one listening on IP6. Either way. Notice that my copy constructor and copy assignment are deleted because it doesn't make sense to have 2 people holding the same, handle to the same socket. Don't want that. But it does make sense to transfer ownership, and so I support move construction and move assignment. And my listener, when he creates, the listener comes back with accept from a socket, he creates a thread, he's going to move that thread into the client handler. Okay? Return, giving that client handler the socket resource, and now he doesn't have it anymore, and he shouldn't have it. And I can say, if I wanted to, the name of a socket paren, you know, I have an operator. I don't know that I really use this much at all, but anyway. Now, my socket now has a send function and a receive function. Notice that these don't return an int, they return a bool. But how about if the buffer is full and I can't send all my bytes? So let's go look at the send. Peek at send. So while bytes left greater than 0, send until all the bytes went, and I'm done. And by the way, I'll return false if I ever get an invalid socket, meaning anytime in this process, the client closed down, or the other end, the receiver closed down. Piece of cake. How could it be so easy? And my receive, full, same idea.
Professor,
While bytes left, receive. Yes.
during the send, when the, for example, when I'm sending data and the other side closes,
Yep.
already all the
The
data
socket
in
will
the
come
buffer.
back as invalid.
Yeah, at that time, do we need to flush the buffer? Queue?
There is a way to do that. I haven't forced that. I think probably the socket library shouldn't, because, you know, each application might have its own cleanup strategy. So I didn't do it. I think I didn't do it. I didn't do it. No.
So I will, like, whenever I invoke, if that happens, I will.
Yeah, see, there's no, for sending, receiving is another, for sending, there really is no way to, you know, if the client shuts down, it's the client's buffer that you're filling, not your buffer, okay? So how do you clear it? He closed, how do you clear it? You can't. But for the receive, that's another story. I think I didn't clear it. Let's see what I did do. I don't remember, but I shouldn't have, you know, my mental model where my head is right this moment, I shouldn't, because my application might have some strategy for trying to recover, okay? But let's go take a look and see what receive does. Yeah, I'm not. So I'm not trying to clear that buffer. Okay. Now, because this, see, remember that this client handler is connected to one client, and if the client closed down, that client handler is going to close. And so that buffer is going away. Okay. And so you don't have to worry about somebody else getting those bytes. It's going to go away. But that's, you know, because each client has his own client handler. But they have a shared queue. There's dropping, each one shares, you know, and I'll show you how that happens. It's not a static queue. In SMA, we used a static queue. Because WCF hid all that stuff from us, we couldn't hand everybody that. So, but here, we're writing all that stuff. And so now, we're just going to give each guy a reference. The receiver each receiver owns this receive queue. And when the client handler is constructed, he's given a pointer to that receive queue. That's what he uses.
Every connection will have its own receive and send.
No, the receive, all the receives share a queue. Remember the single-threaded department. So I want every client to drop his messages in the same queue. If there's two different communication systems, I don't want that to happen, but it won't. So each receiver, okay, is hosting multiple clients, and all those messages are going in the same queue. And his main thread, his receive thread, he's going to pull those messages out one at a time and process them, which is exactly what you really want to happen, because you don't want 14 different threads trying to open files randomly around your, okay, because you'll get these conflicts all over the place. I don't really think that's a performance advantage. You know, if my queue isn't empty, I'm busy all the time, okay? And if I really want, you know, if I want to use more cores, I can have that thread that's pulling stuff. He can spawn child threads if he wants to. I don't think the communication channel should make that decision. Communication channel's job is to make it safe.
He might be getting multiple chicken requests
From
the
different
client,
clients, you bet,
from
absolutely.
different clients, and they will be queued, right?
Yep.
And I understand each client will be a separate process for us. We need to-
Each client handler is, but all the client handler does is pull a message out of the socket and drop it in the queue. That's all he does.
Okay, so we might, so the receiver will have a common buffer for all of them.
Common queue, receive queue, blocking queue.
I'm talking about this buffer, this method over here.
No, that's the socket's buffer. So each client has its own socket buffer, but what's happening is that the receive thread is pulling stuff out of that buffer, framing messages, and then dropping the messages into this shared queue.
Are we defining any designated amount of buffer size for every?
I am not trying to manipulate I'm using the default socket buffer size. I believe there's a way to change that, but I'm not. We don't need to, because you say, how about if I send big files? We're going to chunk files. I'm going to show you how that happens. We're going to chunk files into messages. Yes, works. Yes. Okay, and now there is send stream that returns the size. These are really just tiny wrappers around send and receive. But for a stream, if I really want to implement a stream, so I'm inserting stuff into a stream, that's the right way to do it. Okay. And it'll work just fine. And I don't remember, but I may have used that in my file transfer. No, I didn't. I know I didn't, because I'm sending files as messages. But I put it there. Now I have a received string. So our messages are HTTP style messages. Being the header is string, terminated by a new line, terminated by a new line, blah, 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 blah. Okay. So I have a received string, which by default will go to the end of the string, but we are going to use a new line terminator. Okay. And so this pulls this out with a new line. Now, I intentionally leave this terminator on what's returned. A lot of functions and a lot of libraries will strip off that terminator, but I don't. I want it in there, but I have a function, remove terminator, that remembers the kind of terminator I have. It just goes to the last character and removes that. Okay, and you'll see me, if you look deeply in the code, I'm not going to show you this morning, but you'll see me use the remove terminator. And then I have bytes waiting that lets the application ask for, do you have some bytes in your buffer so I won't block? I'm not going to use that because I don't care if the receive thread blocks. It's just fine. But I put that for applications where, I want to use this socket package for other applications than just this one COM channel. Okay. And so it's useful to avoid blocking. This will be a blocking call, send and receive are blocking. So receive is a blocking call. And so this bytes waiting just tells me if there's something, so that I wouldn't make that call. But you don't have to worry about that. We're going to let that receive thread block if he doesn't have anything, because that's all. His only job is to pull stuff out of that socket and frame messages and put them in the shared queue. All his job. I have a wait for data that allows a client to give the server time to start up. Very often servers take longer to start up because the bind operation can take some time. The server may take a little longer, and so this is here for a client to wait for a while. So this is the total time to wait, and this is some fraction which I've got to check to see if I've got some, I've got some data to start, and if it is, then I start processing. But I don't want to wait forever because maybe the server never got started. I do eventually want to return, with false because the server just didn't start up. Then I have, shut down send, shut down receive, shut down and close. And valid state, I can see if my socket is in valid state. And then, here's some stuff that is just Windows API type stuff. So that's really the sockets package. Now, no, that's the socket part of the sockets package. Now there is a socket connector, and all he does is he adds connect. Okay. He does the, he deletes the so that the compiler won't generate them, because even though they're deleted in the base class, the compiler would still be willing to generate these under some conditions. So he deletes these, and he implements the move, okay, move construction and move assignment. But his main job is to connect. And so what he does, if we peek at that connect, there's quite a bit of low-level detail that has to do with getting this IP6 address set up, and I'm going to skip over all that. Okay, so IP6, IP4 is fairly straightforward. The addressing is basically a pointer to a structure that has the address information. But IP6, there wasn't enough room, so you got a whole bunch of stuff, but they didn't want to tear apart, they didn't want to change so they made a pointer that goes to a pointer, that goes to a pointer, and data structure here, data structure there, it's complicated. So, and I figured it out once, and then I forgot it. I don't want to remember. There's only so much stuff that fits here. And there's some stuff, so I very carefully archived, it's all here, so if I need to reconstruct that, I know where it is, I can go look at it, get study it again, and okay, yeah, it's but I hit the kill switch, gone, okay, it's archived, I don't need it, don't want it, purge it from memory. Don't want too many page faults. Okay. Too many page faults slows everything down, so, especially as you get older. But anyway, so finally, here is my connect. I'm actually calling the Windows API connect, and here it is. So that's connect. Now, listener, what does he do? So all he does is add the capability to listen. So what has he got? He's allows me to construct it with a port and an IP address, which by default the setting is IP6, but it can be this can be an IP4 indicator. And I'm defining the move, construction, and assignment. And now I have a template method called start. And I'm passing it an object to tell the listener, here's your job, here's what you do. So I can change it. Most of the time I don't want to. I want to do it the same way. But I could, there is a mechanism called select, for example, that I'm not doing, I'm not using, but some servers use it. And I could do a startup method that used the select mechanism rather than what we're doing. I haven't thought about it much, but let's take a look at that start function. Let's see what's going on. Remember, this is the listener. So I have a bind function that is doing a little bit of stuff and then calling the platform API bind. So that's associating my listener with a network card. And one of the things you can do is you can bind to the first address you get, or you can bind to all the addresses that are available. And by default, if I remember correctly, I'm binding to all of them. But if you take the first one, sockets are smart enough to give you, I have on my machine, I have a real network card, and I have VirtualBox